Alright guys, good morning. I am out today, hopefully, because I'm taking my middle one to the orthopedic, surgeon, but he doesn't need surgery. He broke his arm at school on Wednesday at PE, and he needs his cast. So, the only thing left we have to learn this unit is how to calculate molecular formulas. So it's not complicated, it's really just one more step past empirical formulas. So I wanted to film this video, this is exactly how I would have presented notes to you if I were here on the Hovercam. So grab your notebooks, take these notes, and we'll work a few practice problems at the end, and I'm assigning you a couple of practice problems to do yourself. So before we get started, just remember the difference between empirical and molecular formulas. You don't have to write these down if you know this information. Empirical formulas are the simplified version of the molecular formulas. Okay? The empirical formulas simply tell us the ratio of atoms in a compound. Like for every carbon, there are 3 hydrogens. Okay? Molecular formulas actually tell us the entire structural formula of the molecule. Okay, so I've gotten a few questions in tutorials over the last few days that I want to address. When you see something like this, where it just gives you a molecular formula and asks you to write the empirical formula, there is nothing complicated about this. It's simply asking you to take the structural entire molecular formula and simplify it. Okay, so C6H12O6 would just be CH2O. C3H6 would just be CH2, and Na2O2, technically guys, that is an ionic formula, so you would not want to leave it in this form anyway. Like, you always want to simplify ionic compounds anyway. Okay, so it would be NaO. I also want to point out, if you had something like, I don't know, C5H8, I don't even know if that's a real compound, I just made it up. If this were the molecular formula, you could also call that the empirical formula because it's in its simplest form. Okay? So in forensics labs, fancy machines can take a substance and analyze it and give you the ratio of atoms in that substance. So it will basically tell you the percent composition of a compound. Okay, that's what we did on Wednesday. We took those given percent compositions of compounds and we calculated the empirical formulas. Okay, so if in that lab, if they also happen to have the molecular weight, in other words, just the molar mass of a certain compound, then you can determine the substance's molecular formula. Okay, because you can tell based on the mass of that empirical formula and the mass of the molecular formula how many times the molecular formula is. Okay, if that doesn't make sense, that's fine, just bear with me. So in order to calculate the molecular formulas, before we jump right in, I just want to line out these steps for you. You probably want to jot these down, although half of these steps are just me summarizing your empirical formula steps. Okay, so if you know how to find the empirical formula and you have that already in your notes, you don't have to write all of this. Okay, so if I'm going too fast for you, you can just pause the video. Your first step is going to need to be to determine the empirical formula, right, using either the percent or the masses given. Remember, you can assume percents equal grams. Again, you wrote this already in Wednesday's notes, not yesterday. But in a nutshell, just in case, step 1 is to assume your percents are grams. Step 2, divide all of those given masses or percentages by their atomic masses. Okay, that will give you the moles of each of those atoms or elements. Divide all of those moles then by the smallest. Make whole numbers if necessary. We wrote down our little cheat sheet on Wednesday in our notes for just common decimals you might get and how to make those whole numbers, or you could just play around in your calculator. This gives you the simplified ratio of atoms in a molecule. Okay, those numbers that you get at the very end of each of those little those little calculations are your subscripts for your empirical formula. Then, if you are provided with the molar mass of this molecule, then you would divide that by the mass of the empirical formula. So all of this work that you do, you would calculate the molar mass. Okay, that's going to give you this thing that I call the whole number factor, WNF. Okay, and that's what you multiply all of your subscripts by to get your molecular formula. So pause this if you still need time to write down these steps, because I'm going to move on, and I've written a couple of practice problems for us, and these practice problems also have us practicing getting the empirical formulas. Okay, so you might recognize this one as the warm-up that you did on Thursday, but now I have, oh, there go my lights. Now I have given you the molar mass of vitamin C. Okay, so you've already calculated the empirical formula of vitamin C. If you still have that work, feel free to just glance at that and start your problem at calculating the molar mass. I am going to go through it, mostly just to make sure we're good with calculating empirical formulas. So vitamin C is composed of 40.91, percent carbon. This is a fresh printout, so it looks like it wasn't totally dry. 4.58% hydrogen, and the rest is oxygen. If the molar mass is 180 grams per mole, determine the empirical and molecular formulas. Now, I just want to make a note, guys, that sometimes you might be given the empirical formula. Okay, so if you are already given an empirical formula in your problem, then you would skip all of this first calculations of empirical formula. So, to calculate the empirical formula of vitamin C, I'm going to take all of my givens, right? I'm going to assume those are grams. So I've got 40.91 grams of carbon, 4.58 grams of hydrogen, and the rest is oxygen. So 54.51 grams of oxygen. My next step is I need to get those into moles so I can determine my simplest mole ratio. So divide everybody by their atomic mass, and you get 3.41, 4.54, and 3.41. Okay, now sometimes people freak out at this step because they're like, oh my gosh, how am I going to get all these into whole numbers? But you have to remember that you still have another step before you get to where you need to worry about that part. You still need to divide by the smallest of these numbers. Okay, so 3.41 is the smallest. Obviously, the carbon and the oxygen are going to be 1 each, and the hydrogen comes out to be 1.33. Okay, so these are supposed to be your subscripts, right? But you can't have CH1.330. So we need these to be whole numbers. This one that ends in 0.33, if we were to multiply that by 3, that would give us a whole number. And remember, whatever you do to one, you have to do to everybody. Gotta be fair. So these are my subscripts for my empirical formula. So my empirical formula is C3H4O3. Empirical formula. Okay? Now, it told me that we actually know the molar mass of our molecular formula, the entire structure of one molecule of vitamin C in a mole. So, if we calculate the mass of our empirical formula, which I've already done for you, but you would put in your calculator, you know, all these atoms and their masses, and you get 88 grams. Okay? If we know that if the molecule is supposed to weigh 180 grams, right, we can determine how many of these empirical formulas would fit into the molecular formula. So 180 divided by 88 gives us 2.00 something. Okay, so that's close enough to 2. I don't know what just happened. Hopefully that didn't blank out on you. So my whole number factor is 2. Okay, you're not done yet. You need to realize that this means that your molecular formula is actually double this ratio. So your molecular formula is actually C6H8O6 for vitamin C. Molecular formula. Okay, so try this next one. You'll need to jot that down in your notes. I don't have that printed for you. And give it a try. And you can check the solution to this one on It's Learning. I'll load these notes up for you. And you can check your answer to this one. And lastly, I want to scoot it down just a little bit because these are your practice problems. Okay, on that same worksheet you've been doing percent composition, empirical formulas, and molecular formulas from. Number 23, okay, pick A or B. And then from number 24, A, B, and C, you just need to pick 2. Okay, so you have 3 practice problems to do for Monday. And I'll try to get a key uploaded. I'm sorry I didn't do that yet for the other night's homework. And then lastly, a reminder, guys, our penny lab is on Monday. We're going to find the percent composition of a penny. It has to be made in 82 or later. Okay, before 82, it was 100% copper. Now they've added in zinc, and we want to know the percent comp. Alright guys, hope you guys have an awesome day and a good weekend, and I will see you on Monday.